Sorry for the break. It was my power, my laptop that had the issue. Although we were almost done at that time, but we just need to look at a few things before we go. Let me bring up the course material up again. We have exhausted that of the slide. Can you see the material now?
Okay.
So let's look at, we are trying to look at these questions. Can you solve any of these questions? Which of these questions can you solve? Now look at the question of the answer to the question of that first one. Hello, can you hear me? Hello?
Yes, yes, sir.
Good. You said if the refractive index of the cladding material is higher than that of the core material of the fiber, the incoming light will undergo total interlight reflection. It is so because when the light travels from a rarer to a denser medium, it bends towards the surface. It bends towards the normal. It bends away from the normal. Thus, the light rays on the core cladding tassel will, instead of coming inside the core, get refracted into the cladding material. The answer is not really good enough, but there will be no total internal reflection. That's what is the answer, the summary of that answer.
The answer is down. It's not, this one is solution. The question you asked is terminal question. So
no, I'm talking about the SAQs.
No, I know, but like the question you were talking about is about refractive index.
No. What I'm talking about is this. I'll show you what I mean now. This one.
Like,
what
I thought you said about the equation. Okay.
No. I'm talking about this question. What will happen if the refractive index of the cladding material is higher than that of the core? That is what I'm asking. So that's the answer there. But I don't totally agree with the answer. I don't totally agree with that answer. What I will say is that in the first, if it is higher, there will be no total internal reflection in the other material, which will make what's it called? Which will make which will result in power loss. So that is what it means. But you can go through the answer and modify this one. So this is the second one. This is a solution and answer. Solution and answer. This is the second one. I guess this is the one I'm talking about. Let me just go there. I'm not talking about this one here. Okay, I'm talking about, okay, now this. If the core and cladding reflective rate for a step index fiber is 1.47 and 1.46 respectively, what will be the broadening of a pulse after a distance of 5 kilometers? So this is the formula you will use. So the distance L is the distance, that's the 5 kilometers. The refractive index of 1.47, 1.46 and 1.47. Then what is our C? What is our C?
should be 3 times 10 raised by 8 speed of light, I think.
Okay, let's confirm that. Velocity of light. Okay. That is it. So you should be able to solve that. Let's go back to the question you are now referring to. Let's look at the summary. Said an optical fiber consists of a transparent glass core and a cladding of lower refractive index. So the cladding must have a lower refractive index. Please note that. Since the refractive index of the cladding material is lower than that of the material, much of the light is launched into one end, will emerge from the other end due to a large number of total internal reflection. So the what's it called? The lower material, since the cladding is of a lower refractive index, there will be total internal reflection. So basically, there will be transmission of pulses. We now say that in the step index fiber, the refractive index changes suddenly at the core cladding interface. Changes suddenly is not the same thing as decreases continuously. The step index fiber is talking about changes suddenly. The change might be up or down, but in the gradient index fiber, we talk about decreases continuously from the core axis. Can you see the difference?
Yes,
Can you
sir.
see the difference? Change can be increase or decrease, but in the gradient index fiber, there is decrease continuously from the core, but there will be change in the core cladding interface. So you should note the difference. Use the right word if you are asked to write. So the maximum entrance core angle, also known as acceptor angle, is a measure of the light gathering capacity of the fiber and is given as that. So the term, this is known as the numerical aperture of the fiber. So you need to read the material. Anyone you don't understand, you bring it to class. And we have talked about pulse broadening due to pulse broadening. So this is the formula for pulse broadening. We said L is the distance, these are the refractive indices, and C is what? Speed of light. And we said pulse broadening can be greatly reduced if, instead of step index fiber, we use gradient index fiber. It is so because green fiber, through different rays, traverse different optical paths in the core. They also take time in traveling through a given length of the fiber. Now, so the material dispersion, I think we are yet to touch that actually, because it is in the topic of next week. Is that clear? Hello?
Yes, sir. Yes, sir.
It is in the topic of next week. So we'll touch more on that next week. So these are the terminal questions. Attempt it, and the ones you cannot get correctly, you can get back to us next week. I guess this is a good way to stop or to end the class. If you have any question, can you please bring it up now? John
No,
Daniel,
sir.
any question?
No, sir.
So thank you for joining the class. As I've said earlier, if we are to meet next week, we'll meet next week by the grace of God. But if you're ending the class next week, that means we have 2 sessions next week. This is the 6th meeting. We will have the 7th meeting tomorrow, but most likely we have the 8th meeting as well. So thank you. Have a lovely night and the rest of the day.
Thanks, sir. Thanks, sir.